Alright, today we're talking about Chapter 4, Section 7, Variation. Now we're going to be, these are probably going to be the easiest word problems you have done. Now, I hope that's a true statement. Yeah. I, I really think it is. I really think it is, okay? All right, here we go. So starting off, in application problems, we are often concerned with exploring how one quantity varies with respect to other quantities. Variation equations allow us to show how one quantity changes with respect to one or more additional quantities. In this section, we will discuss direct variation, inverse variation, and then a combination of the variations. We start by introducing direct variation. So first things first, we have direct variation. For an equation of the form y is equal to kx, okay? Now y is equal to kx is saying that y varies directly with x, okay? Now let's do this real quick. All right, if we were to say that y varies directly with x, we might do something like this, okay? So that just think about this intuitively. If something varies directly, then we would say, that they're equal to each other in some way, right? Right. Well, they can't be exactly equal to each other because that is a very direct variation, right? It's simply a one-to-one variation. If y is equal to x, then whatever y is, x is, right? Well, that's why we have to include the k. Okay, that k is called the proportionality constant. We're going to put it behind there because I'm not going to fit it in front. But in all of these problems, what you're going to do is you're going to have to figure out what that constant is. Okay, in every single one of these problems, step one is figure out what the value of that constant is. Okay, and then step two, we'll be able to answer the problem that's given to us. But anyways, this is direct variation. Y is equal to k times x. All right, it's a direct variation. We are simply multiplying it by k. Okay, so let's see what we're talking about here. All right, so example 1 reads, suppose y varies directly with x. Alrighty, so we are told right away that y varies directly with x. Okay, so what this tells me is I'm obviously going to be using that variation equation that we used at the very beginning, like just 10 seconds ago, right? And suppose y varies directly with x, and y is equal to 20 when x is equal to 8. So this y is equal to 20 when x is equal to 8. This is going to tell me what my k is. Okay, so let's just go ahead and begin. Okay, A reads, find an equation that relates x and y. Okay, so again, x and y vary directly. So we can just go straight to that equation that we saw on the previous page. Y is equal to kx. Right. Now, in order to find k, so looking at this problem, we have we have three unknowns, right? We don't know what y is in this equation, we don't know what k is in this equation, and we don't know what x is in this equation, right? Well, in order to find out what k is, we must know what y and x are. Well, luckily, they are given to us, okay? And of course, that's what we see right here. So, we're going to substitute 20 in for y. That's equal to, and then 8 in for x, so we're just going to put 8k there, right? I just put 8 in for x, right? And so this means if I solve for k, I end up with k is equal to 2.5, right? I just divide both sides by 8, so k is equal to 2.5, right? So this tells me what my k is. So now my equation is now going to be it's no longer going to be y is equal to kx, right? It's no longer going to be this, because in order to solve problems, we need to figure out what that proportionality constant is. We figured it out. So now my equation is going to be y is equal to 2.5x. Okay, and that concludes A. We have now found an equation that relates x and y. And from that equation, we'll be able to solve anything that gets thrown at us because we figured out what that proportionality constant was. Okay, and of course B, so B reads find y when x is equal to 12. That's going to be super easy, right? Y is equal to, right, and again, we have the 2.5, and we're given what x is, and x is 12. Okay, and then 2.5 times 12 is going to be equal to 30. Okay, so y is equal to 30, and that's it. Again, step one, figure out what that proportionality constant is. You're going to be given the tools to figure out what the proportionality constant is, right? And I guess that might just be the hardest part of this. And then once you get that proportionality constant, right? Once you get this equation, you'll be able to solve, solve for y, solve for x, doesn't matter what, if you are given the opposite, right? If you're asked to solve for y, you're going to be given an x. If you're asked to solve for x, you'll be given a y. All right, so next up, suppose that y varies directly. So we're again told that y varies directly with x. So this tells me I'm going to be using that direct variation equation that we learned from the very first page. All right, so y varies directly with the cube of x. So we're going to say y, okay, it's going to vary directly. So we're going to have a k times x, okay, but not just x because this says with the cube of x. So we're going to put a cube here. Okay. And then from here, we're going to substitute in our y and x. Okay, so again, first thing that we did was figure out what the equation was. The second thing we're going to do here is we're going to plug in the x and y's to figure out what my proportionality constant is. So 375 is y. That's equal to k. And if I plug in a 5, I'll just go and do it. And then this means that 375 is equal to 5 cubed is 125, so 125k. And of course, if we solve for k, we would divide both sides by 125, and therefore we would have k is equal to 3. Okay. All right. So now we got what the k value is. Actually, that shouldn't be in green because we're trying to get the equation. So we will do this. K is equal to 3. Okay. So this means that my equation, because A wants us to find the equation is going to be y is equal to 3, because that's what k is now. Okay. 3 x cubed. So we figured out what the equation is. And now B wants us to find y when x is equal to 2. A little bit of mental math here, right? So I'll write it down though. So we have y is equal to 3, and then when x is equal to 2, so we have 2 cubed. All right. Well, what is 2 cubed? 2 cubed is 8. 8 times 3 is 24. So y is equal to 24 when x is equal to 2. Okay. So every single problem that we're doing today, I think there's like 11 of them, are that easy. Just figure out what the proportionality constant is, and then from there we'll have our equation, and from that equation we can solve whatever problem they're throwing at us. Okay, because we have to figure out what the equation is first. So in order to find out the equation, we find the constant, and then we can proceed. So pretty sure the next one's going to be a word problem, an actual word problem, like with actual things here. Let's see. This might be useful. Yeah, good. All right, so this is a nice, actually good, tough word problem that you will feel very accomplished for doing whenever you complete it. Okay. All right, so starting out, this reads, the kinetic energy of an object in motion varies directly with the square of its speed. Okay, so we have kinetic energy varying directly with the square of its speed. Okay, So if a van traveling at a speed of 30 meters per second has 945,000 joules of kinetic energy, how much kinetic energy does it have when it's traveling at a speed of 20 meters per second? Okay, so the first thing we need to do is we need to look at this first sentence. Ooh, that's a horrible line. Look at this first sentence, right? Um, and figure out what that equation is. Alrighty. So the kinetic energy. So I'm gonna put a big K for kinetic energy. Okay. Um, it says the kinetic energy of an object in motion varies directly. Okay. So a direct variation normally would be kx, right? So this time it's not just simply kx. It's going to be k because we need to know what that proportionality constant is. But instead of x, it's going to be s because we're talking about speed. Now we could use x and y's if we wanted to, but doing this really helps us kind of keep our ducks in a row, right? I mean, big K for kinetic energy, and honestly, let's just go ahead and use let's use an E for kinetic energy. Just make it easy, okay? I'm pretty sure it's K in physics, but for college algebra, and so there's no ambiguity between the K's, I'm going to go ahead and use an E. Okay, so the kinetic energy of an object in motion varies directly with the square of its speed. Okay, so the speed must be squared. Easy enough. All right. Okay, so now the next sentence reads, if a van traveling at a speed of 30 meters per second has 945,000 joules of kinetic energy. Okay, so this is going to tell us what E is and what S is, and therefore we can figure out what K is. Okay, so if we fill in those blanks here, if a van has 945,000 joules, so 945,000 joules is equal to K and then S squared, so it's going to be 30 squared. Okay. And then we're going to solve for K, 30 squared is 900, and then we're going to divide both sides by 900. Oh, that's not my calculator app. We are looking at 1,050. Okay, so K is going to be equal to 1,050. Alrighty, so now we figure out what K is. So now we have our equation. Our equation is going to be E is equal to 1,050. Okay, we figure out what the K is times S squared. Okay, so now we can answer the last sentence. Now, the last sentence reads, how much kinetic energy does it have if it is traveling at a speed of 20 meters per second? So we were trying to figure out how much kinetic energy it has. So what we're going to do is we're going to solve for E here. Okay, so all we're going to be doing is plugging in 20 for S. So we're going to have E is equal to 1050, and then 20 in for S, 20 squared. And so 20 squared is 400, and 400 times 1050 is 420,000. Okay. So by using the information given to me, I was able to figure out what the equation would be. Okay, figured out what the equation would be. All right, but in order to actually use that equation, we need to figure out what K is. We need to figure out what my proportionality constant is. All right, once we figured out what my proportionality constant is, I plugged it in to my original equation. Right, this 1050 is taking the place of this K. And then from there, I can answer any question you throw at me. All right, whatever question you have, we'll play ball. Right, depending on if you want to know what the energy is, if you want to know, well, for instance, if this question here was, how fast do you have to be going to have, 1 million joules of energy? Well, then you would just simply put in 1 million for E and then solve for S. Take the square of both sides and so on and so forth. But that's honestly as hard as this might get. Did I do that right? Okay. All right, now obviously there are indirect variations, things like that, but I mean, as far as word problems go, that's really it. Right, but of course we're going to do another one. Okay. So the ponderal index measures the leanness states. The ponderal index measure of leanness states that body mass varies directly with the cube of the height. Okay. All right. So that's going to tell me right now the body mass varies directly with the cube of the height. Okay. So what I'm going to do is I'm going to make an equation. So we're going to put an m for mass. Okay. So m for mass, because that would be the body mass. And it varies directly with the cube of the height. So we would say, instead of kx, right? Kx would be normal, but instead we're going to use better variables here. Okay, so we're going to say h for height, and it is the cube of it. Okay, so figuring out the original equation looks like this. Alrighty. Now I have to figure out what that proportionality constant is. So on to the next sentence. The next sentence reads, if a, quote, normal person who is 1.2 meters tall has a body mass of 21.6 kilograms, okay, so this tells me what I need to know to figure out what K is. So let's put it in yellow. So the mass is going to be 21.6, and that is equal to K, which we are trying to figure out, and then the height was 1.2 meters, so 1.2 cubed. Okay, and so this is going to tell me what my K value is, so let's figure that out real quick. So I got 12.5, so K is going to be equal to 12.5. And now from there I can make my equation. I have m is equal to 12.5, again that takes the K, and then h cubed. All right, now we can figure out what the last sentence is. Then what is the body mass of a normal person that is 1.8 meters tall? Okay, well we just have to figure out m. That's not going to be hard, because we're just going to say, okay, so m is equal to 12.5, and then 1.8 meters tall, so 1.8 cubed. So that's going to be 1.8 cubed times 12.5. 72.9. Okay, and that should be the mass of somebody who is 1.8 meters tall. That's 72.9 kilograms. Right. So next thing we're going to talk about is inverse variation. Okay, so this is the second part of our variation. We're just doing the inverse of it. Right, and it's let's see here. Let's actually just go ahead and we'll snip this, and then I'll explain it. I mean, there are a lot of stuff here, but it's just explaining the relationship between both of these. So the inverse variation equation, okay, in its simplest form is just simply y is equal to k over x. Right? Now y is equal to k over x. All right, if you think about if something very directly, then we're multiplying x and k at the same time or by one another. Okay, because we are having a direct variation. Okay, but if we have an inverse variation, then we can still have the k out front if you want. Okay, so if you want to still have the k out front, that's fine. If this is what you like, that's okay. All right, and then it'll be 1 over whatever the inverse variation there is. Okay, so what we're going to do, I mean, that's really about it. I mean, I don't know if there's much else I can say there. I think that's really about it. You know what? I'll go ahead and snip this down here because, as I've said plenty of times before, these authors are a lot more eloquent with their words than I am. Okay, I'll keep that there. All right, so let's go ahead and just do an inverse variation. We're going to keep it light, keep it simple, and do x and y's like we did at the beginning of the section. Alrighty, so here we go. So this is inverse variation. So suppose y varies inversely with x. Okay, so this tells me right away it's going to be an inverse variation, right? And then we have and y is equal to 72 when x is equal to 50. So that's going to tell me how to figure out what k is. So we need to set up this equation. Okay, so we're going to have, oops, it's not equal to. We're going to have y is equal to, and again, it doesn't matter what you would want. If you want to do k over x, that's fine. But for now, I'm going to go ahead and do it this way because I feel like many students might see it better this way. We're going to do y is equal to k and then times 1 over x. You know what? I'm going to do it both ways because I do prefer this method, but again, I mean, it's up to you. But anyways, doing it like this, okay? So we need to figure out what k is. So we're going to be doing the substitution that's given to us. We're told what y we're told what y is when x equal to some number, and so from that we can figure out what k is. So we can do 72, and that's going to be equal to some k times 1 over 50. Okay, and then if we did it down here, we would have 72 is equal to some k over 50. Right, and then as you can see in both occasions, what I'm going to be doing to solve for k is multiplying both sides by 50. Right, I'm multiply this side by 50, that cancels out. I multiply this side by 50, so 50 times 72. And then down here, I multiply this by 50. Again, same cancels out, and then 50 times 72. Okay, so in both instances, you multiply by 50 to get rid of that fraction, or to get rid of the 50 on the right side, rather, right? And if I do that, 72 times 50 is 3,600. So in both cases, k is equal to 3,600. Okay. I actually knew that because, well, whatever. All right. So anyways, that's what k is equal to. All right. So my equation is going to end up being y is equal to 3,600 over x. Right. That's my equation for a. And if we were to, then let's see if we can fit b in here. Okay, find y when x is equal to 45. Well, y is equal to 3,600 divided by 45, and that's going to be 80. Okay, and that's it. That is inverse variation. All right. So let's look at another problem. And we're going, oh, nice, good word problem that you probably, you know, prior to this lecture be like, I'm not doing that. But here's what we have. It's a good one too. I like it. It has the word density and stuff in it. All right. So, density of an object. For a given mass, the density of an object is inversely proportional to its volume. If 50 cubic centimeters of an object with a density of 28 grams per cubic centimeter is compressed to 40 cubic centimeters, what would its new density be? Again, looking at this problem, you might just be like, oh, this is dumb. My head's spinning, okay? But let's just attack this one sentence at a time. For a given mass, the density of an object is inversely proportional to its volume, okay? So, for a given mass, the density, okay, we're going to use D for density, of an object is inversely proportional, so we're going to say K over something to its volume. Well, that's easy. It's going to be V. All right. Well, that's my equation. That's as hard as it gets. All right. Next sentence: if 50 cubic centimeters of an object with a density of 28 grams per cubic centimeter is compressed to 40 cubic centimeters. Okay. So This one might not be as apparent, okay? Because we're not given. Let's see, how can I word this? We're not told the two numbers we need to figure out what the equation is, but you just kind of have to use the word problem. Okay, so uh, yeah, I hate to say this, but you kind of have to think a little bit. All right, I'm not saying that as an insult. I'm only saying that because I said that that these word problems today are going to be super easy. Um, but I mean, it's not as linear as maybe I had hoped. Um, but yeah, you do have to think a little bit. And of course, I'm probably going on a little bit too long because you've already figured this out, haven't you? We're just going to plug in 50 for I don't know why my throat sound like this. We're just going to plug in 50 for my volume and 28 for my density to find K. So doing that, um, so 28 is my density. K over V, what my volume is 50, right? That's cubic centimeters. And then multiply both sides by 50, so we have 50 times 28. So we're going to have 1400. So K is equal to 1400. Ooh. And then from there, I know that my equation is going to be D is equal to 1400 over V. Okay, and now we can proceed with our problem here. Well, the rest of the problem rather. All right. Okay, yeah, sorry. And then we're going to compress this particular object to 40 cubic centimeters, okay? Again, that volume. And it's asking what is the new density? Okay, well, obviously since we're given the volume, well, we're just going to plug that in for V. And doing so, we're going to get density is equal to 1400 over, we're compressing it to 40 cubic centimeters. So 1400 divided by 400, I'm sorry, 1400 divided by 40 is 35. So my new density is going to be 35 grams per cubic centimeter. Okay, and again, I probably went on a little bit too long about that particular problem. I think y'all would have figured that out. I don't know. All right, even more nice, good word problems. I'm pretty sure there's 11 today. Forget. Alrighty, so the shutter speed S of a camera varies inversely. Okay, so this is pretty much telling us the variable, right? The shutter speed, so S, right, of a camera varies inversely. Okay, so this is going to tell me we're going to have a K in my numerator. Varies inversely as the square of the aperture setting. As the square of the aperture setting. Okay, and the aperture is going to be used or going to be given as an F. Okay, and it's the square of it. That's it. So now let's figure out what K is. So figuring out what K is, we're going to, all right, the next sentence reads, if the shutter speed is 125 for an aperture of 5.6, okay, so 125 for the shutter, and that's going to be equal to, we're trying to figure out what K is, and then 5.6 for the aperture, 5.6 what, I don't know, and then of course that is squared. So this tells me I'm going to square 5.6. So 5.6 squared is 31.36, and then we're going to divide 125 by that. So we have 3.98. It's 3.99. So K is equal to 3.99. Right? And yeah, that was, sorry about that. I divided, I meant to multiply. It's 3920. If you were following along and you're like, that doesn't seem right. Right, so yeah. So K equals 3920 if we multiply both sides by 5.6 squared. All right, so now this tells me that my equation is going to be, S is equal to 3920 all over my aperture squared. So what if we continue on with this particular problem? What is the shutter speed if the aperture is 1.4? Right. So all I'm going to do here is plug in 1.4 for f. So 3920 and then 1.4 quantity squared. So divided by 1.4 squared. So 2000? Does that sound right? Yeah. So my shutter speed is going to be 2000. I don't know, like it's weird just calling shutter speed 2000 and aperture 5.6. But anyways, that's it. We did shutter speed. So hopefully you see what I mean by these are probably going to be the easiest word problems you've done, because all you have to do is figure out what k is, and once you figure out what k is, it's all downhill from there. And even then, figuring out k isn't even that hard, I think. Okay, so we'll go ahead and snip this. We're not going to read it all though. I guess we should read some of it. Like I thought there were going to be a definition somewhere. Okay, so we'll go back and look at the high points there. Okay, so next thing we're going to talk about here is going to be combined variation. Okay, combined variation is exactly what it sounds like. So far we've been doing direct variation and inverse variation. A combined variation is going to be both. We're going to be varying directly with some variable, and we're going to be varying inversely with some variable. Okay, and it's going to behave exactly like you think it will, and you have to use the words that are given in the problem to determine, all right, am I putting this number in the numerator, or am I putting it in the denominator? Right? Let's see. Yeah, let's just go with the problem here. I feel like I can explain things better by doing the problem. Alright, so suppose y, okay, this is good. So we're going to have y. We're going to suppose y varies directly with w. Okay, so we're going to vary it directly. So kw. I'm going ahead and putting this in a numerator format because, I mean, I'm expecting, you know, a combined variation problem. Right. So if it varies directly with w, so I'm going to put w, I'm going to multiply it by k, and inversely with x. So that means I'm going to put the x in the denominator. And that is literally it. That's all I have to do. If you're told something is varying directly with you know y or whatever, you're going to put it in the numerator. If it's varying inversely, you're going to put it in the denominator. That's it. Okay. So let's proceed here to figure out what k is. All right. So y would be equal to 240 is equal to, again, we're trying to figure out what k is. W is going to be equal to 20, and x is equal to 4. Okay. And from here, right, so 240 divided by 4 is 60, and then we're going to divide, we're going to then divide both sides by 20, so we're going to have k is equal to 3. Okay, just some mental math here. Again, I just divide by 4. I know that's 60, and then I multiply divide by 20. So that's that. So k is equal to 3. So now my equation, all right, so this would be A. My equation is going to be y is equal to 3w over x. And that's my equation, right? And then B wants us to find what happened. We're going to find y when w is equal to 10 and x is equal to 3. And we could probably do some mental math here, but yeah, let's do this. Let's go y is equal to w is equal to 10, so we got 3 times 10 over 3. So 3 times 10 is 30, divided by 3 is going to be 10. So y is going to be equal to 10. Okay. Well, I believe that's it. Ooh. Oh no, Sherman, why did you do this? Okay, so This is a problem with trying to do mental math sometimes. You get ahead of yourself. At this point, I for some reason I divided both sides by 4. I don't know what I was thinking. Again, you're probably on your end going, well, why are you dividing by 4? I should have multiplied by 4 there, shouldn't I have? So maybe I need to work on my mental math as well. So yeah, in order to solve here for k, I need to multiply both sides by 4, and we're just going to write this out as to avoid any more mistakes. So 240 times 4 is going to be 960. So 960, and that's going to be equal to 20k, and then 960 divided by 20 is going to be equal to 48. So this means that k is going to be equal to 48. Sorry about that. What was I doing? Oh yeah, and so my equation, I guess I don't have to write the equation here yet. My equation, if we wrote a here, would be y is equal to 48w over k. All right, and then we'll do the substitution again. So we have y is equal to 48, and then what was w? W was 10 over k, which was, I'm sorry, over x. Oh my goodness, y'all didn't see that. Over x, which is 3. And then we get 48 times 10 is 480. 480 divided by 3 is going to be 160. All right, so that was a nice exercise in don't trust your brain. And this is actually B. Yeah, sorry about that. You know, I have these from time to time. I don't think I've made a mistake like that in a while though. So it is what it is. If we were in a classroom, I guarantee you somebody would have said something though. Alrighty, so no shortcuts, no mental math. This time we're just gonna go hard at this and prove that these are very easy. Okay, but this this particular problem looks freaking long, doesn't it? All right, so here we go. The number of gallons of a liquid that can be stored in a conical tank is directly proportional to the area of the base of the tank and its height. All right, so we're just doing okay. So this is called joint variation. So we are varying directly with not one but two numbers. Okay. So the number of gallons of a liquid that can be stored in a conical tank. Okay, that would be volume. Okay, so the volume is directly proportional. So we're going to say K. Okay, it's directly proportional to the area of the base. Okay, so the area of the base is going to be, we're going to put B for that, for area of the base of the tank and its height. Okay, and again, this is joint variation. We're not doing inverse variation or anything like that. This is just simply a joint variation. All right. So a tank with a base area of 1,200 square feet. All right. So this is the sentence that tells us how to find what K is. So let's do that. So a tank with a base area of 1,200 square feet. So this is going to be 1,200 for B. Okay. And again, we're looking for K here. And a height of 15 feet, so 15 for H. And it holds 45,000 gallons of liquid, so 45,000, 000. Okay. And again, all I did here was I followed along the volume, and of course the K, the base, and the height. I just tried to follow along through there. Okay. Right, so luckily for me, this is very, very not tempting to even try to do mental math on. So I don't think there will be any sort of mistakes here. All right, so equal to, and then 1,200 times 15. So 1,200 times 15 is going to be 18,000. So 18,000 K. We divide both sides by 18,000, so 45,000 divided by 18,000 is going to be 2.5. Well, that's pretty easy. So my K is going to be equal to 2.5, which means that my equation is going to be equal to volume is blue. We're going to have volume is equal to 2.5 times the base times the height. Okay. So now we can proceed to the last sentence. How tall must a tank be? So it's asking it's asking how tall must a tank be. So this means that H is now going to be the unknown. So how tall must the tank be to hold 75,000 gallons? Okay. So in order to proceed here, we're going to say 75,000, that is the volume, and that's equal to 2.5. Okay, and the base is going to be 1500, so 1500 is going to take place of B, and we're looking for H. So solving for H, so 2.5 times 1500 is 3750. So let's put this on the next page. Like so. So we're going to have 75,000 is equal to 3750 H. And then we divide both sides by 3750, so 75,000 divided by 3750 is going to be 20. So we have H is equal to 20. Okay, so our tank has to be 20 feet tall in order to hold 75,000 gallons and have a base of 1,500 square feet. Right. So, man, I feel like this is pretty easy stuff. Hopefully you agree. I don't know if it's sunk in yet, or maybe you have to do some problems on your own. But it. I don't remember doing this when I was in college, I'll tell you that, but I don't remember much of my undergraduate anyways. But so here we go, the resistance of a wire. All right, so the resistance of a wire, so we're going to put R for resistance. The resistance of a wire varies directly with the length. Okay, so it's going to vary directly. Is there an inverse? Okay, so there is an inverse. So I'm going to put this a fraction. Okay, so it's going to vary directly with the length of the wire, so K and then L directly with the length of the wire, and inversely with the square of the radius. Okay, so the radius we're going to use a little r, and it's going to be the square of the radius. Okay, so big R is the resistance, and little r is the radius. We could, if you wanted to, I'm pretty sure resistance is also omega for ohms. Let's see, what does the textbook do? Okay, a textbook just uses a big R, so we're just going to use a big R as well. Okay, so this is our starting point. So next up, what we're going to have to do is figure out what K is. So the next sentence here, so a wire with a length of 500 centimeters, so that's going to tell me what the length is. And a radius of 0.5 centimeters has a resistance of 15 ohms. So I'm going to plug in all those into my equation. So 15 for ohms is equal to K, that's what we're looking for. It has a length of 500 centimeters, so 500 centimeters. A radius of 0.5 centimeters, so 0.5 squared. So 15 times 0.5 quantity squared is going to be 3.75. So we're going to have 3.75 is equal to 500K. And they're going to divide that by 500 to get a K value of 0.0075. Okay. All right. So that's what K is. This tells me my equation is going to be R is equal to K, which is 0.0075 times the length, all over the radius squared. All right, then we can look at the last sentence now. Determine the resistance, so we're just going to look for a big R. So determine the resistance of an 800 centimeter piece, so 0.0075 times 800, because that's 800 centimeters in length, and it has a radius of 0.8 centimeters, so 0.8 quantity squared. So solving for this, holy smokes. So the numerator turns out to be 6, and then we divide it by 0.8 squared, so we have 9.375. Okay, and if that's yep. All right, good. So that's how we did this problem, and that is the combination of varying directly. We vary directly with the length, and inversely with the radius. Okay. So again, in each of these problems, you're going to be told exactly what you have to do. You just kind of have to execute it. Not kind of execute it. You have to execute it. Okay, and I'm pretty sure this is the last example. Yeah. Alrighty. We chugged through a lot of examples today. That's how you know it's easy. We're able to chug through a lot of examples. Alrighty. So, for a fixed speed, the number of calories burned while jogging varies jointly. Okay, so we're gonna be varying jointly with the mass of the jogger and the time spent jogging. Okay, so the number of calories burned. So we're going to say C for the number of calories burned. All right, and it's going to vary jointly. And again, jointly is basically just having two or more what the heck is it called? Variations within a problem on the same line, right? Two that vary two that vary directly, or two that vary inversely, something like that. So in this particular case, it's varying jointly. So we're going to have K, because we're looking for that constant. It's going to be varying jointly with the mass and the mass of the jogger. So we're going to put M for mass. And the time spent jogging, we're just going to put T for time. Okay. All right. So that's not too hard. So now we move on to the sentence that tells us how we figure out what K is. So if a 100 kilogram man jogs for 40 minutes, okay, so, and he burns 490 calories, so we're going to proceed there. So we're going to say he burns 490 calories. Okay. This is a 100 kilogram man that jogs for 40 minutes. So it's going to be K times 100, and he jogged for 40 minutes, so times 40. Okay, so this tells me K is equal to, all right, so 100 times 40 is equal to 4,000. So we're going to take 490 and divide it by 4,000 to get 196. So K is going to be equal to 196. Is that right? No, it's not right. I forgot a parentheses. I'm having a rough go today. All right, so 0. Let's put this on a line beneath it. So this means that K is equal to 0.11225. Okay, that makes sense, right? Because this is 4,000, and 490 divided by 4,000 is not going to be a number greater than 1. But anyways, so that's K. So the next line is the one that we really need to figure out. So how many calories will a 130 kilogram man burn if he jogs for 60 minutes? So my equation, calories, that's equal to, and then my K is 0.1225. All right, his mass again was 130 kilograms, so 130. And he jogs for 60 minutes. So I just basically have to multiply all that together. So 0.1225 times 130 times 60. So he's going to burn 955.5 calories. Right? Whew, that's it. that does conclude today's lecture.